Direct address mapping, physical address is divided into how many parts? 3 parts. Correct or not? One is word offset, second with the block offset, and third one is the Hello students, welcome to the Preplara. So we'll continue with the problem solving on cache address mapping, that is part 2. In the part 1 lecture we have seen, like we have solved some questions on direct address mapping and associative and set associative. I'll be continuing with a few more questions. Look into the question here. The first question 1 says here, carefully understand, consider a machine with a byte addressable main memory of 2 power 20 bytes, blocks size is 16 bytes, and direct map cache is having 2 power of 12 cache lines. Let the addresses of 2 consecutive bytes in a main memory be they given in terms of hexadecimal, and what are the tag and cache line addresses in hexadecimal for a main memory address of this one. See, ultimately what they are testing this, the main memory address pattern in terms of hexadecimal they given. They're asking that how many bits are allocated for, like what portion of the tag, what portion of the tag and cache line only they're asking. How we can answer it is, first of all, we have to understand that what is the physical address given and look into the cache. So look into cache and convert into, anyway they given direct address mapping, need to be find out the tag bits and word bit, how many word offset required and block offset required. So quickly look into a question here. What is the physical address given? What is the physical address? So how to know the physical address? Please do understand. They said, consider a machine with a byte addressable main memory of 2 power 20 bytes. Sometimes they may give 2 power of 20 instead of 2 power 21 megabytes, meaning is same. 1 megabytes we can express into 2 power of 20. So directly 20 bits is a physical address. Your physical address is 20 bits. So just tell me, under a direct mapping, under direct address mapping, physical address is divided into how many parts? 3 parts. Correct or not? One is word offset, second with the block offset, and third one is the tag. Am I right, all of you? Yes. Just think yourself. Now word offset means what? Word offset nothing but word number within a block. So I think they given block size how much? 16 bytes. If the block size is 16 bytes, please do understand all of you. If the block size is 16 bytes, how many bits required for word offset? This is depends on the block size only. So to address the 16 bytes, 1 byte out of 16, how many bits required? This is 4 bits only, all of you know. Now block offset depends on number of blocks. First of all, we need to find out the number of cache blocks. Number of cache blocks. How to get the number of cache blocks? Very simple, cache size. What is the cache size? Cache size by block size, but already given, you understand. Direct mapper cache having 2 power of 12 cache lines. Already given number of cache blocks. How many number of cache blocks? How many are there? 2 power of 12 cache lines are there. This is nothing but 4K only. Yes or no? 4K blocks. 2 power of 2 4. 2 power of 10 is what? 1K. 4K 4096 blocks already there in a cache memory. Then how many bits required to address the one of them? So now look into the power value. This is only indication. So 12 bits required for this, 12 bits. So 12 plus 4, how much? 12 plus 4, this is going to be 16. For a tag, it is going to be 4 bits only. But does it require this information? Yes, we may require. Look into the question. What are the tag and cache lines of address of main memory address? This one. So you can see. So they said main memory bytes are like consecutive words given, consecutive byte address given in terms of hexadecimal. One of the address he has taken from 2 and asking the tag line and word line, tag and cache line only. Fine. So just take it, this address E201F. Let me write properly. E201F. So try to write the like hexadecimal pattern. Each digit you have to represent into 4 bytes. E how to write? 410, 2 is 0010. This is 0 means 4 zeros, 1 nothing but 00001, F nothing but all ones. So you can check it. What is the length of address we got? 1, 2, 3, 4, 5. 5 bit is there, right? 5 digit, 5 into 4, 20. So you can check it now. 20 bit address, yes, 20 bit is a physical address, correct or not? Yes or no? Yes. Now this entire address, the 20 bit address need to be divided into what, 3 parts only. What are the three parts here? What are the 3 parts? Word offset. Word offset, how many bits required for, sorry, word offset, how many bits? 4. Block offset 12. Divide it. 1, 2, 3, 4. This is 12. 1, 2, 3, 4. So like this is 8 till it will go, correct or not? This is what word offset only. Sorry, it is going to be block offset. This is word offset. Am I right? And this is tag. Now, what is the question they are asking? What is the question? What are the tag and cache line addresses for a main memory address this? So in terms of hexadecimal they are asking. In terms of hexadecimal they are asking. Getting my point? For a tag, look, this is a tag. This one only tag 11110, that is nothing but E only. Yes or no? E only. Then cache line nothing but your cache block only. Line address in terms of what? How we can write it? This is going to be 201 only, correct or not? Your answers would be like, option would be 201 comma E. Option B was like E comma 201. Option C 201 comma F, like this. D suppose none something. So if the option based question is there, this is obviously option based only. I did not mention. Your answer goes tag plus line, right? This option B is the right answer for this question. So simply you must understand the main memory word pattern and byte address pattern also. Means you understand 1 megabytes of memory, we have to write the addresses, right? Byte numbers in terms of hexadecimal only there. But some parts they wanted to ask, like what is the tagline, what is the cache line? Easily we can answer it. I hope you got. This is a little variation of the previous question. And so overall this session, what I want to discuss, just please do understand, all of you. So most of the students have a confusion of the word range, word addressability, byte addressability, and how these words are mapping, and row major order, column major order. So this kind of things are little bit confusing, so that we'll work out in these problems. I hope end of the session you will be very clear with this concept of row major order, column major order, word range and block range, and this kind of questions usually we answer it. Look into the next question, all of you. Look, second question. It is interesting. This question was asked in CS 2013 paper. This paper made by IIT Bombay. In a k-way set associative cache, the cache is divided into V sets. So first of all, you have to make a habit yourself. While reading only important information, try to capture, so that answering question becomes very easier. This set, the k-way set associate means immediately your mind has to go, there are 3 mapping methods. So we need to go k-way set association, the information. So number of sets divided into sets, V set, cache of which consists of k lines. Please do understand, k lines means there are k number of blocks are there, V number of sets are there. The lines of the sets are placed in a sequence one after another. So lines of a sequence, lines of a set are placed one after another only, because yes, in a set, so concept, you have to take any block of main memory, map to the set number. Within a set you can place it anywhere, but how you are placed sequence only, one after another. First 0 position, 1 position, 2 position, 3rd position, like that you have to notice, one after another. The lines in the sets are like the lines in a sets are sequenced before the lines in a set S plus 1. Please do understand this point, you have to understand. So accessing also, like the lines in a set S are sequenced before the lines in a set S plus 1. First S, then S plus 1, like that. The main memory blocks are numbered 0 onwards. Main memory blocks are numbered 0 onwards. The main memory block number J must be mapped any one of the cache line from dash to dash. That is a point they are asking. So ultimately, if you take please do understand overall concept. If you take any block of main memory, you are mapping to set. Within a set, there will be any number of block you can place it. they're asking that what is the range of a set, like what is the, from where to where I can map this block, that is asking. Let's take an example, like so, like no small data, then we can answer this question. Getting my point? Look carefully. So this is main memory, okay, main memory, please do understand. This is main memory. So main memory is divided into blocks only. Main memory is divided into blocks. Main memory. Suppose 0, this is 1, this is 2, this is 3, this is 4. Like this, suppose capital M minus 1 are there. So total, fine. So we used k-way set association, k-way set association. K-way, they mentioned it's k-way set. So in a k, let me use a 4-way set association. 4-way set association. 4-way, fine. 4. Are you getting my point? Let me also consider cache memory. Cache memory, okay, cache. So in a cache, let me take number of blocks here. Let me take 1, 2, 3, 4, 5, 6, 7, 8. So numbering 0, 1, 2, 3, 4, 5, 6, 7. Total number of blocks in main memory, sorry, cache memory 8. In a main memory, M minus 1, some number is suppose 64 or 32 block, you can take it. So what is the mapping goes? What is the mapping goes? Like any block of main memory, any block of memory, suppose if I take jth block of main memory, you have to map to set. So 4-way set association meaning what? In each set there must be 4 cache block. But in the question, k lines are there, k cache block like that. So how to get the number of sets? Simply number of sets representation, let me take V equal to total cache blocks. How many are there? 8. What is the way of set association? 4. How many I'll get? 2 sets I'll get. So 2 sets, let me divide like this. This is what set number 0, set number 0, set number 1. So without taking this all the things also, you can easily be able to answer the question. But getting more clarity, what is the range of the set? Let us understand with the example only. Fine. 2 sets we got, set number is set number 1. Each set, so what is each set containing? Let me take different color to understand. Okay. You see clearly, this is a set number 1. This is set number 0, set number 1. This is 4 blocks are there, 4 blocks are there. Please do understand. K-way set association, K lines will be there. 4-way set association, 4 blocks in one set will be, that you have to notice. So any number block, any block, suppose J block, I am numbering to J. So now what is the mapping says? Any block of main memory, you have to map to the set. So J modulo, number of sets, how many we got? 2. So that I am representing into V only. See, J modulo we have to perform. This will give the position, like either set number 0 or set number 1 give. Let's take an example. Suppose if I take 3 modulo 2, number of sets, so right? 3 modulo 2, what is the value? 1. Set number 1. In a set number 1, you have to place. The option is that's what this method is more flexible. What is the flexibility? So in a set number 1, there are 4 cache block or there, you can place anywhere. How to place? One after another one. I am placing 3 here. Getting my point? Suppose 5, I want load it. 5 modulo 2. What is the 5 modulo 2? Again 1. So it is mapping to set number 1. Where to place? This position only, like this. If I want to map like 4 modulo 2. What is the 4 modulo 2? 0. This is not set number 0, you can place here. Then anything comes with sequence, you have to place it. Now, what is the question here? Any block if I take, it is coming to one set. So what is the size of the set? It will be there, like example I said 4 modulo 2. 4 modulo 2 we got 0. Set number 0, you have to map it. If set number 0, where I can place 4? 4 you can place here, 4 you can place here, you can place 4 here, you can place here, correct? So this is my range. So range of a set from 0, 1, 2, 3. Getting my point? My range of set from 0 to 3 is there. Option. If I want to map 5 modulo to 1, set number 1 also have 4th. This is the 4th block to 7th. This is what range. I can place in between anywhere. That's what flexibility to me. So that only question they ask. See. So any they are asking block main memory block number, any block number map to this set line from where to where they are asking. So now how we are mapping? Any block number J modulo set number ko you have to map it. That giving what? That is giving the set number, you can place it. So now answering this question very simple. I have to find the set range only. I have to find the set range. How to get the set range? You can see set range. Okay. Please do understand. Set range I am taking. Set range. So now set number 0. What is the range for set number 0? 0 to 3. Correct or not? Set number 1. What is the range? 4 to 7. Correct or not? So now how many blocks are there here? 4 blocks. Here how many blocks are? 4 blocks are. Suppose set increase, the range also will change. Suppose set number 2, if it is there, it will start from 8 to something, 8 to 11. Set number 3, like that it will go. Suppose any set number, set number how we are getting here? How we are getting set number? This set number 0, set number 1, set number 2, like that. How we are getting? So J modulo V only, please do understand. So please do understand with the previous slide, J modulo V giving the set number. Okay, getting my set number. Okay, this is set number. Okay, for this set number, range nothing but how many blocks are there? I have to multiply with the range. Range is to size. The size of the set number depends on the k-way set association or 4-way set. In our example, 4-way, but generalization k. Okay, k. So it will work or not. 2 from year to year. So again, J modulo V into k plus I have to add extra k minus 1. Whether it will give or not. See, in our example, suppose if I take set number 0, J modulo V, what will give me? Set number 0 into k nothing but size 4. Suppose 4, 0 into 4, 2. This also 0 into 4 plus 4 minus 1, 3. So what is the range? This is 0 to 3 will get it or not? 0 to 3 will get it. Got. So it means, so like no 0, like no please it start 0, then size minus 1 only we have to add it. I hope you're getting my point. Range. So this is the way we can get this is only answer. J modulo V is giving the set number for which you have to multiply the size of the set. So that will give the initial starting of the set, starting of the range. Ending goes nothing but you have to add extra k plus 1, k minus 1 you have to add, k minus 1 added. I hope you're getting my point. This pattern will work for anything. Like suppose there are 1000 sets are there. If 1000 sets are there, if you want to know size of the 500th one, 500 into size you multiply to, then 500 into that size plus extra what k minus 1 you have to add it. So whether this is correct or not, you can check with the options. Are you getting? We can check with the options. Fine. Look. So first of all, so answering this question, that much analysis also not required. If you know little bit concept like a set association mapping function, we have to taking jth block of main memory mapping to number of sets, right? Number of set they given already V and block number J. So my mapping function goes J modulo V only, correct or not? Wherever J modulo V is there, then we have to look remaining we can eliminate. You can see option A J modulo V. Option B J modulo V. Option C J modulo K. Correct or not? So J modulo K is there. Getting my point, all of you? J modulo K. J modulo K eliminate directly. Option D J modulo K. We are not mapping into size of the set. Please do understand. Jth block of main memory we are not mapping into size of the set. We are mapping to number of sets. Number of sets already given. V sets are there. So directly straight away option C and D eliminate. We can eliminate. Then look into option B. J modulo V is correct. 2 to J modulo V plus K minus 1 is there. But you know what I said, to getting the range, something you have to multiply. Right? So J modulo V, please run. This J modulo V giving the set number only. But set number giving, but if size nothing but size of set nothing, but you have to multiply size of the set. The size of the set giving K. So this option B also can be eliminatable. Now look, see, J modulo V is the set number will give, multiply with the size of the set, the initial starting of the range, like starting the set number will get, then range nothing but extra you have to add k minus 1. So then you can compare with our answers. Answer for this question is the option A. I hope you're getting my point. Look carefully. This is our, see, J modulo V into K, J modulo V into K plus K minus 1 extra we have to add. What is size extra? This was, see, 0 to 3. How much added for, for 3, if I add, for starting of the position 4, if I add 3, 7 you will get. Then starting next block will be, next set will be 8. 8 plus 3, 11. So 11, then next we'll start 12, 12 plus 3, like that you will go. I hope you're getting my point. So this is a range of question you can understand. This could be a word range in a block, or set range in a cache memory. Getting my point? Or you understand, like the same, like cache is given number of set. If I want to say the set number, this is the same formula I can use. Suppose if I take main memory cache block is the cache block having some this many words. If I want to know the word range, then also we can get it this point. I hope you getting my point. So another pattern of a question we're looking into, look carefully here, another pattern. Question number 3, it is a little interesting question. Consider direct map to cache of 8 blocks is used for implementing following program segment. How many blocks are there? 8 cache blocks are there, direct mapped. Program is there, float, 10 by 10 array, int. This is some values I'm storing in this array, fine. Float element occupies the 4 bytes, the block size is 12 bytes, and array is stored in row major order. We must understand what is the meaning of row major order and find the number of its in a cache. Ultimately, they are asking, and also assume initially cache is empty. Initially, some point is missing. You assume it the initially cache is empty. And suppose any so like syntactic of the program segment is kindly ignore. Only we need to consider into semantic of this program here. Ultimately, there is an array of program segments. Some program segment is there that initially stored in main memory. When I want to map this program into main memory to cache memory, how many its are possible, or what is the it ratio, how many misses possible or misread? This kind of question we can expect here. So answering this question, first of all, try to know the size of the program here, the size of the program segment. So this size of the program segment depends on my element only. The float element, if you see, how many elements are there? 10 by 10, nothing but 100 elements are there. Yes or no? Array will access 100 elements, right? This repetition of 2 loops, this A of I comma j, you can say 100 times will repeat, 100 elements are there. What is the float element occupies? 4 byte into 4 byte. Please do understand. Now it goes, program size going to be 400 bytes. Am I right or not? This 400 byte program we need to load into main memory, that later we need to map into direct map to cache of 8 blocks are there. Are you getting my point? How this program has been loaded into main memory? Which format? Row major order. There are 2 formats we have. You might be studied from data structure, row major and column major. Most of you know, but still I am trying to say what is the row major order, column major order. Just look into the way of storage of row major order, then we'll work out how many number of its will get it. Getting my point, all of you? Look, this is the main memory. Okay, main memory, fine. Please do understand. This is your main memory. So initially main memory also divided into blocks only, correct or not? Blocks only, blocks. So main memory some size is there. Now what is my program size? 400 bytes. Getting my point? My program size, what is program size? 400 bytes we got. So this 400 bytes we need to be arranged in terms of blocks only. 12. So what is the block size? 12 bytes, correct or not? Please do understand. Now, so program segment size is 400 bytes, okay, fine. So number of blocks required to load this program, number of blocks required to store this program is 400 bytes by block size 12 bytes. So how much will get? Byte cancel, 33.33. So now I need how many blocks? 34 blocks required, sorry. We need 34 blocks required. Are you getting my point? Suppose somewhere, if I start storing from here, if I start storing from in a main memory, program segment if I start, not required to start program storing from 0 onwards. It can start from any address, like maybe 0 or anything you understand. I started, if I start 0 block, 1 block, 2, 3, like this. We need 33. 0 to 33, total 34 blocks. Total 34 blocks required to store your program. I hope you're getting my point, all of you. Fine. So each block store how much data? Each block store 12 bytes. And also we need to understand each block So each block occupies how many elements? Each element taking 4 byte. 4 if you divide, 3 elements are there. 3 elements will be there. I hope you're getting my point. Each block can occupy 3 elements, that you have to understand. So additional other point we need to take it. Which format we are storing? Program initially we are loading main memory. What order? Row major order. Row major order. What is the meaning of row major order? Array is accessed A, I, comma, J. Getting my point? A, I, comma, J only, right? Yes or no? First row would be like, A of. So you check the array started with 0, 0. Yes, 0 onwards only. Fine. So now first array will be, first element is A of 0, 0. And second element is this 0 of, this is 1. So first entire row you have to store, and second row, third row, like row major means entire first row, like, so like I'll show you that. A of 0, 2, like this. So A of 0 of 9, this is what first row. Okay, this is a first row. Getting my point? So first entire row will store in memory, then second row will start loading into memory. That's what row major order. So if I started program segment here, my first element will be, let me write A of, simply I am writing A of 0, 1, 0, 0 will be there, A of 0, 1 will be there, A of 0, 2 will be there. I hope you're getting my point. This is a block, because block occupies how many elements? 3 elements. Next element will be A of 0, comma 3, A of 0, comma 4, A of 0, comma 5 will be there. Next A of 0, comma 6, A of 0, comma 7, A of 0, comma 8. Getting my point? Then A of 0, comma 9. Next A of 1, comma 0, A of 1, comma 1, like this. Please do understand. Once row finish, next row will start. This is a way of storing into main memory. How you be getting this? What a row major order. If I talk about column major order, that will be different. Column by column it will store. We'll see that part also. I hope you're getting the way of storage of a row major order in main memory. Fine. Got the point, all of you? Fine. So next we need to look into cache part. So look carefully, how many cache blocks are there here? So direct map to cache, 8 blocks are there. Direct map, 8 blocks are there. So let me write here. Fine. Okay. Let me take cache memory. How many blocks are there? 8. Please do understand carefully, because many things we can observe with this data. 1, 2, 3, 4, 5, 6, 7, 8. So number of cache blocks are 8, correct or not? So let me write 0, this is 1, index 3, this is 4, 5, 6, 7. Getting my point? So also main memory is there, right? Main memory. So same thing is there, like, somewhere it is started. 0, this is 1, this is 2, this is 3, this is 4, 5, like we have 33, correct or not? So for understanding purpose, let me take here only, because I need to do mapping here. First element is what? A of 0, 0, A of 0, comma 1, A of 0, comma 2, A of 0, comma 3, A of 0, comma 4, A of 0, comma 5, A of 0, comma 6, A of 0, comma 7, A of 0, comma 8. Getting my point? Like this data is there. Fine. So initially cache is empty. Now CPU start generating the address, correct or not? Fetching the values. Getting my point? We need to understand initially cache is empty. Now what is the question here? How many hits are how many miss only? So the way you understand, first initially I loaded my program in main memory, some address onwards. Which order? Row major order I stored here. So now the CPU started executing the first instruction. First reference goes A of 0, 0. First reference goes this A of 0. Whenever physical address comes, first eventually we'll search in cache memory only. That under direct mapping how we can search it. Suppose with this address I am searching. Do we have A of 0, 0 in a cache memory? Do we have this reference? No, because cache is initially empty. no free fetching is done, that is nothing but, please do understand, this is going to be miss. M nothing but miss, you understand. The reference get miss. So whenever something you search, something you search in cache memory, if it is miss occur, obviously what we need to do, the concerned word, just take the same physical address, visit the main memory, entire cache block we need to be placed into cache memory. Entire the block of main memory you have to place into cache memory. The concerned word we are hand over to the processor, correct or not? Now A of 0, 0, when miss occur, then this entire block from main memory you have to capture. So just same address I went, main memory, where A of 0, 0 present here. That is what 0 block here. Because I numbered from, the address would be something, but I am just taking as a 0 only. No harm at all. So now this block we need to place it. What is the way of placing? Same k modulo n. Do you remember? This is 0 modulo 8. What is the value? 0 only. Correct or not? There are 8 cache blocks are there. 0 block of this program segment. 0. So that means we have to place it here. Getting? So the words will come. A of 0, 0. Then A of 0, 1. Let me write short form. A of 0, 2 will come. Correct? Getting my point? Now the later we given to the processor. Next time the processor generate address for A of 0, 1. Getting my point? So is there, it is there in a cache memory? A of 0, 1, yes, present. So I will write H. H means it. This is present. So thing which you are searching in a cache memory, it is present, that we can say it. Getting my point? Yes. Then next. So next reference by the processor, A of 0, 2. Is it present, A of 0, 2? Yes, present. That is also 8. Fine. So next reference goes A of 0, 3. Is there A of 0, 3? No, this is miss. When this word is miss occur, the entire, the concerned block from main memory need to be placed into or mapped to the cache memory. A of 0, 3. A of 0, 3 present. A of 0, 3 present where block number 1. Getting my point? Block number 1 only. So 1 modulo 8. What is the value? 1. So we have to place it here. So now A of 0, 3. Getting my point? A of 0, 4. A of 0, 5. I hope you are getting my point. Short form writing this array, A of 0 of A of 5 will be there like this. Now 0, 3 miss. Then next A of, yes, if the reference goes A of 0, 4, it is going to be it or not. So now try to understand the analogy here, then make how many its will be there, like this also will be it. Total how many references are there here? Please do understand. Total how many references are there by the process? How many references? Means depends on the number of words. How many words are there? How many words are there? How many elements are there? 100 elements. So maximum number of elements. So maximum number of references. Total number of references will be, total number of references. References goes how many? 100, right? 100. Now please do understand. First reference, first block, any block you have something you take, first reference is miss, second next two references are going to be it. Correct or not? First references, next two will be it. Am I right, all of you? Just observe here. So like, how many total blocks are there? How many total blocks are going to be referred here? 0 to 33, right? Total 34. So what is the scenario? So when 400 total memory size, total program size 400 bytes divided by 12 bytes, we got 33.33. Getting my point? So 33 are full block and the last block is there. This last block having only one element, that A of 9 only. Getting? So remaining elements are not being utilized. So total reference goes like, please do understand. So I'll be writing like this. Okay. Out of 100, please do understand, 33 blocks are full. Getting? 33 blocks are, there are 3 elements will be there. Getting my point? And the last block having only one element. 33 is a 99 plus 1, 100. Am I right? This total 100 or not? I hope you're getting my. 33 blocks are full. Each block having three elements. And last block having only one element. Total 100 words are 100 elements, you understand. So out of these 3, please do understand, out of these 3, first two reference is what? Miss, next two will be hit only. So now please do understand, I will write it, this total reference go continuous only. So 33 into 2, please do, 32 into 2 are it. Getting my point? So 33 into 1 will be miss. And last one also, last block may only one video, that is also miss. Please don't. This is misses, number of miss. This also miss. I hope you getting my point. Misses, miss. This will be it. It's. I hope you getting my point. There are 33 block. First reference is miss. Next two references are it. And last block only one word is that is going to be miss only. So now total number of hits will be how many? This only, right? Total number of hits will be 66 only, right? So if I ask the question, hit ratio. So what is hit ratio? Total number of hits 66 by total references into 100. This is going to be 66%. What is the miss rate? What is the miss rate? It will go 34%. Am I right? 33 plus 1, 34%. This is the way we can understand. I hope you're getting my point. So just look carefully and understand what I did here. Very simple. First of all, I understand the organization of the memory pattern. Then, so I started referring by the processor. Then like how many hits are going to be observed very clearly. Suppose question goes here. Suppose instead of row major order, if I repeat this question, if I repeat the question for column major order, then how many total number of misses will be there? If I ask question, start workout and comment on this video, ma, please. So I'm repeating the question, same thing question, please work out with the column major order. Column major order, let me give the clue how the way of storage here. 0, 0, 0, 1, 0, 2, right? Entire row will store, then second row, third row, it is going row major order. Column major order, nothing but instead of 0, 0, it will go, first element will be like, let me write column major order. So column major order will go like this. First 0, 0, okay, first element. Second element will the, please don't, column will, so first I will increment. So getting my point, 1, 0, then 2, 0, like this, 3, 0, and 4, 0, like this, 9, 0, fine. Next. So next one, 1, 1, 1, so 1, 0, 1, 1, sorry. So next, see, 9, 0 after that, so j will increment 1, I will be same only, I, 1, 0, okay. So this will be 1, 1, so this will be 1, anyway 1, 0 is 1, 1, 2, 1, getting my 3, 1, 4, 1, like that it will go. So when you store first three element in the block, then you have to imagine that how many, like every reference going to be missed. So this I am giving, like you can evaluate yourself that how many the total number of miss can happen if the array is stored in a column major order in memory and accessing row major order. Storing in column major order, accessing this order only, find out the number of misses will happen with this. So means what? The performance of the cache is not only depends on the size of the cache and associate which I used, the program structure, the way of storage of the data structure also importance that we need to notice. Fine. So I hope you got something from this question. So similarly, we'll see another type of question. Let me go. Look, fourth question here. This question was asked in CS like 2007 paper. So what we can understand, it is similar kind of program segment we stored, some different, like we can understand different nature we can get it from here. Consider a machine with a byte addressable main memory of 2 power 16 bytes, total size of the main memory given. Assume that direct map data cache consisting of 32 lines, means total number of blocks in cache memory 32, you understand. The blocks is 64 byte, each used in the system. A 50 by 2-dimensional array of bytes is stored in the main memory, starting memory from location, this given hexadecimal, 1100 hexadecimal. Assume that the data cache is initially empty, clearly mentioned initially empty. The completely array is accessed twice, 2 times accessed. During this, assume that the content of the data cache do not change in between the two access. So nothing is changed between the two access here. how many data cache misses will occur in total? The previous question I asked, its and program segment was there. Here I am asking in terms of total number of data cache miss, how many elements are going to be missed here. So answering this question, you must know the memory size, we know, number of blocks. Anyway, cache and main memory need to be organized block wise. And also there's the program segment. In a previous question, they did not mention where the program started loading, but they specified here from some address onwards only it is stored. So that we need to consider carefully. And here, how many times access same program? Twice. Then how many number of miss will be there? First of all, tell me the program size simply. What is the program segment size? What is this program segment or array size here? So 50 by 50, this is nothing but 2000, sorry. So 2500, they said 55, 50, 2-dimensional array of byte dimension. So 2500 bytes array is there here. Okay. So what is the block size is? What is the block size? 32 lines are there. So block size are 64 byte. So we need to arrange in terms of block, right? I need block size. What is the block size is 64 bytes. So we need to divide it. So let me do it this one. Suppose if I take main memory. Okay, main memory. Okay, main memory. Getting my point. Carefully observe, all of you. Okay. They said clearly program is being placed some address on. What is the address? 1100H, hexadecimal notation they given. Getting my point. From here to this stored here, program started storing here. Okay, program started storing program here. So how many blocks required to store this program? So program size how much? 2500 bytes. Okay, number of blocks in a for storing this one, number of blocks will be 2500 byte divided block size is 64 bytes. 64 bytes. Divide it, how much will get? Approximately 40 blocks will get. Am I right? 40 blocks. Calculate it. So 2500 bytes with 64 bytes will approximate 3.39 point something. That nothing but definitely 40 required, because extra definitely is some fraction value we cannot keep into, we cannot leave that one block compulsory required. 40 blocks required, but last block may not be fully utilized. And also we can understand each block size, one block size, what is the like how many elements can be stored in the one block, that we need to understand. How we can get it? So in a question, see, 50 by 50 2-dimensional array of byte, this also byte only, one element size byte, and my block size is 64. That means 64 elements we can keep, that we need to understand. One block, please do understand, this is some information. Block, one block contains 64 elements, please do understand. 64 elements we can keep it, that we can notice. So then 40 required. So I'll start from here. Some we required 40 tak. But what is the starting address here? So total, what is the main memory size? What is total main memory size? 2 power of 6 byte they given. 2 power 6 byte. So if I divide with a block size, how many total blocks will get? Getting my point? Are you getting my point? 2 power 16 by 64, if I do, 1024 will get. Like, suppose started here, some 0, 1 something. So it will be the 1023 blocks. Total main memory contains 1024 blocks. Now, my program we started loading some address, the 1100H onwards, and it's going to be occupy total 40 blocks. What is the number it is? If I decode hexadecimal to decimal, so what is the address I'll get? 1100 means what? You can convert. So each bit you can express 001, 0001, and 4 zeros followed by 4 zeros. Correct? This is your physical address. Okay. Now what is the block size? 64. 6 bits required for block offset only. 4. This is what? Your word offset only. So remaining will be there. This is 2 power of 0, 2 power 1, 2 power of 2, 4th position. This is 64th position. Nothing but you understand. Block number 68. Please do understand. My program has started storing 68 block number onwards. and it is going to be occupied 40. So now 68 plus 40 means 39. If I add, how much will be there? This is 7, this is 107. So somewhere like 107 that it will be like my program, this entire program content. But this is not required to be like, you can consider from 0 onwards also. There is no harm, because same thing only, like wherever you start, that is going to be map only, right? But just from given on data, we have to understand, right? We have to understand, like, total main memory contains 1024 blocks. My program has placed the block number 68 onwards. It is going to occupy next to 40. 68 plus 39, 107 is the total blocks occupied by my program. That we have to notice. So this is a 68 block. 68 first block map to the cache, that will go. Or you imagine the program you start storing from 0 also, there is no harm at all. Same concept goes only. But given thing we understand, fine. So like, please do understand given things, how to trace out from the given data. That only we understand here, fine. So answering this question, this all not at all required. So just analyzed only, fine. So what is the question? Let me take previous slide. What is the question here? That this entire array is accessed how many times? The complete array is accessed twice. Assume that content of the data cache is not changed between that. How many data cache miss will occur in total? But we have to map to cache, right? How many cache memory blocks are there? 32, right? So the initially cache is empty only, that we have to notice. Fine. So let me take cache part now. Cache memory. Getting my point? So cache. So if I ask a question, what is cache memory size? Simply number of cache block multiply by cache block size, that you can do. How many blocks are there? Given one, 32, correct? Which are numbered 0, 1, 2, 3, 4, 5, 6, 7, like this. 31. Please do understand. Initially cache is empty. Now this is a main memory. So for analyzing multiple times I'm drawing, but please don't worry about this one, because only we'll get analysis. Like somewhere started 68 onwards, like this. Your program, we started storing, your array started storing 68 block number 2. This is what? 107. Getting my point? So total blocks from 0 to like this, if I talk, so main memory are 1024. This, this gives a lot of understanding about main memory. That is the reason multiple times I'm writing. Total main memory has 2 power of 16 bytes, nothing but 64 kilobytes memory. If I organized in terms of bytes, sir, blocks, 1024 will get. This is 1023 only, 0 to 1023. This is my one. So when you refer, this will go, fine. Suppose now come into CPU. Okay, CPU giving the address to referring the array. So understand here, not mention any row major order, column major order. By default, you understand program has stored in row major format only. A of 0, 0, like this. Please do understand. Two times array, A of 0, 0, 0, 1, 0, 2, like this will go. Getting my point? This is 1 byte. Please do understand. Now, if I take one block is there, block containing 64 bytes. Means nothing but 64 elements will be there. Please do understand. 64 elements will be there. Are you getting my point? 64 elements. More than a row, one block will occupy, because one row contains 50 by 50, right? 0 to 49. So it will occupy more than a one row. It will occupy one block. Please do understand. So first reference comes from the CPU, A of 0, 0. Access also A of 0, 0 only. Getting my point? A of 0, 0 only. So now A of 0, 0, do you have in a cache memory? Please do understand. Do you have A of 0 in cache memory? No. That is miss only, right? That is miss or not? That is miss only. So I'm writing like a miss. So now next one, what to do when miss occur? Same, we have to go to main memory, take the block. So entire block, please do understand. This entire block number 68, we have to direct map to cache, right? 68 map to 32. Or if you are confusing yourself, if you are feeling that confusion is there, what you can do, assume this is a 0 block only. Please don't, there is no ARM at all. Are you getting my point? Assume it this 0 block only. 0 block of the program. So 0 modulo 32 also can write, both meaning is same only. Either actually 68 also can map, or assume that this is a 0 block of total, how many? 40, right? From year to year, we have 0 to 39 blocks are there, right? Either 0 to 39 you can go concept, or 68 to 107 also go concept. Meaning is same only, there won't be any problem. 0 modulo 32 means I will place it here 0. 0 block I place, correct? So next every reference is going to be it or not. Please do understand. First reference got, because 64 elements will come here. 0, 1, 0, 2, 0, 3, 0 to 49 will be it. 1, 0, 1, 1, 1, 3 like that will be it or not. Because there are 64 elements going to be it. Getting my point? Now whenever any next reference comes, that is going to be miss. Getting? That will come from the next block 1. So now initially, please do understand. Initially every block 34, every block has to come here only, right? So 0 block I have to place, 1 you have to place, 2 you have to place, 3 you have to place, 4 you have to place, 5 you have to place, 6 you have to place, 7 you have to place, like this. 31 I have to place it. Please do understand. Now total miss I'll take first axis. Let me write first axis. Okay, first axis. Let me check with the first axis. First axis time. It misses. I'm taking first 32 blocks are going to be missed. Do you agree, all of you? Because first time we have to fetch that block from main memory, so that will be miss only because of first reference of that block. So that is miss only, one miss. I am saying that for each block first one is a miss, the remaining is going to be it. Such how many first references I am checking? 32 it will come. So 32 will be miss is there. But 30 after 31, 32 block also referred, because there are 40 blocks, a total 40 blocks are there. 32, when you map 32 modulo 32, please do understand carefully, this is giving 0. Now 32 replaced here, 32 replaced by, 0 is replaced by 32. Getting my point? Are you getting my point? 0 to 31 first, like I placed, fully cache is full. Now still my program is not completed. A reference comes with 32 block. 32 is not available. That will occur miss. So we have to remove the 0 block. You have to place it, because no option. We have to come with circular, because 32 modulo 30 is giving 0. Like 32 for 33 we have to remove the 31. We have to place it 33. Then 34 remove 2 and place it 34. Like that somewhere it will go. Now please understand 39 tak, like we have to place it here 0 to 39. So now total how many remaining will be missed again? After 31, 40 tak, 8 will be missed. Getting my point? 8 will come to some point, 11 tak it will come. Getting my point? So first access like 32 plus 8, total 40 miss will be there. Getting 40 data miss will be there. Remaining will be 8 only. So when this is going to be repeated 2 times, right? Second access, same array repeating second time also. When second time happens, again it will start generating E of 0, 0 only. Are you getting my point? E of 0, 0. Please do understand. Array first started 0 to 55 tak over. The completely 2 times done. Then again second axis will start from 0, 0, 0. 0, 0 supposed to be here, but that is got replaced by 32 block. So this is going to miss or not? Again you have to go to main memory, place the block number 0. So block number 0 is placed. Next block number 1 is placed. Block number 2 is placed. Like that 39 replaced by some number here. Correct or not? So this how many will be there? Again second axis first 8 will be a miss again. Here tak miss will be there. And this after this data is not replaced. From I can say now it is going to be replaced 11th block tak it will replace only. Correct? 0, 1, 2. Correct, fine. So are you getting my point? So 32, like 39 will be replaced by some number. Fine. So how many will be there? Anyway, see. So previous 8 got replaced, nothing but 8 will be again replaced here. Remaining blocks will be it only. So remaining blocks will be it only. You can count it also fine, this is 35, 36, 37, 38, 39 only. So here only 39, right? 39. Getting my point? So I'll write it. This is what replaced by 35. This is replaced by 36. This is replaced by 37. This is 38. This is 39 and fine. So 39 will be now, second access time. This is replaced by 3. This is replaced by 4. This is replaced by 5. This is replaced by 6. This is replaced by 7. Correct. Now 8 onwards, 8 to 11. So please don't. 8 to 31 thak it will be it only, because these blocks are not been replaced here. So this will be it. But again 32 onwards again going to be miss only, because the 32, 33 blocks are not there. Again it will start from this cycle only. So in a second cycle, first 8 references will be missed. Please do understand, first 8 blocks in a second cycle, first 8 blocks going to be missed. Then after this, 8th to 31 tak is going to be it. Now 32, 33, 34 is not there. Again 8 blocks are going to be missed. So total will be, so now I will be writing here, please do understand, total data misses, total data cache, total data cache misses will be first access, correct or not? First access plus second access, right? Second access, please do understand carefully. First access will be how much? 32 plus 8, and second access first 8 plus and last 8 will be replaced. Total is going to be 56 blocks, you understand? Getting my point? So please do understand carefully. And one more thing you have to notice, if I do 68, so if you take the block number, main block number 68 to 107 also, meaning is same only, same answer will get it. But you may feel little confusion to calculation, because 68 modulo 32, 16 modulo 32, 107 modulo 32, you have to do it. But instead of that, just move your program 0 onwards, like assume that 0 to for 39 blocks are there, you can check the mapping, things will be same only. So out of this question, what we understand, this only majorly, my program, so like given starting address, so by default we assume like program start from 0 onward, but specified address given, how to get that address like hexadecimal to decimal, then we understand 68 how much space is allocating in terms of block, then how we are mapping, so that we understand with this question. I hope we got it. So look into another type of question here. Look, question number 5. This is little interesting question, ma. Please understand clearly. Consider a machine with two-way set associative data cache of size 64 kilobytes. This is lengthy question. This question was framed in GATE CSE 2008. This question was framed for 6 marks. Please do understand. There are 3 questions followed with the same data. 6 marks. So that moment, because so now we don't have a scenario of common data or linked answer type questions. We have straight away 2 marks, 1 mark. But we used to have like before 2012, sorry, before 2013 tak we have like common data question. Fine, look into 64 kilobytes and block size is 16 byte. Cache is managed using 32-bit virtual address, and the page size is 4 kilobytes. Program to be run in this machine begins as follows. This is a program. Some things we need to ignore here, because some things are not required to be answer, not required to be getting your answer, but we can understand the concept, but we can ignore it. Fine. The size of the double element is 8 bytes. Array ARR is located in the main memory starting at the beginning of the virtual address. Please note page number given here, FF40. You understand 1, 2, 3, 4, 5. 5 fours are 5 only. 1, 2, 3, 4, 5. So each element, each digit is 4 bits, right? 20 bits, like my main memory size is 1 megabytes. You understand? Stored in row major order. The cache is initially empty, good, and no free fetching is done. The only data memory references made by the program are those to array of this element only. So memory references which comes to the references came from the CPU to the directly to the array, not to the entire program memory. You want to understand. Question says the total size of the tags in the cache directory. What is the cache hit ratio for this initialization of the program? And what are this question asks like which of the following array element has the same cache index of 0, 0? So we need to answer it. For answering this tag directory, please to understand, we need tag bits. We need tag bits required, compulsory, right? Tag bits required. So tag bits nothing but my address. The cache need to be organized in terms of blocks and sets also. So look carefully at the question. Two-way set association. First of all, out of which we need to get the size of the program, because program segment given, the program try to load into main memory, get the number of blocks in main memory, similarly get the number of blocks in cache memory. So one by one we can get the answers. First of all, just calculate the size of the program. Double element AR array name 1024 by 1024 array is there. So now see, this is array is access, some storing some element here. So 1024 by 1024, correct? This is can I write 2 power of 10 into 2 power of 10. This is 1 m. Please don't know. 1 mega elements are there. Are you getting one? Are you getting my point? 1 mega elements are there. 1 mega elements are there. So they said in a question, one element, one double element taking 8 byte. So one element is taking 8 byte, 1 mega into 8 byte. This is going to be my program size is 8 MB. Please do understand. What is the program size? 8 MB. And to get the tag number, I must know the physical address. What is the physical address? Already given right here, 32-bit. The cache is managed in 32-bit virtual address. Please do understand. So far questions, I mentioned the physical address. Please do understand there are two connections. Cache can be connected to virtual address or cache can be connected to physical address. So directly we can take before conversion from virtual to physical address, we can take the virtual address, we can give into the process cache, or after converting from virtual to physical address, the physical address also we can refer it. The construction may be differ. So you mentioned here cache is managed with 32-bit virtual address. This is only we have to consider. Fine. So now first thing what we got a program size and physical address or logical address, what is address we got, and cache size is 64 bytes is there, and two-way set of source. This information we have fine. So take it like we'll go one by one. First one question we can solve it. So first thing, what is the cache size? Cache size 64 kilobytes. Am I right? Check it. Cache is 64 kilobytes. Block size 16 byte. Fine only. So block size 16 byte. Another thing also given page size also given 4 KB. So that is as of now not required to answer this question. Fine. So first of all, find the number of cache blocks. Number of cache blocks. Number of cache blocks. So I used to represent by capital N, same notation I'm using. So now 64 kilobytes cache memory size by your block size 16 bytes. What is the answer? Byte cancelled. So this will go to 4K. Am I right? 4K only. Any confusion? Otherwise you understand. 2 power of 16. Can I write it? 2 power of 16 by 2 power of 4. This is going to be subtract 2 power of 12. 12 nothing but 4K only. Please don't understand. Now similarly we need to find out the number of sets also, because they given number of sets. If I take S sets, okay, S sets. So number of cache block N divided by way of set association, two-way set association they use 2. So 4K by 2. You will get an 2K sets. Fine. Now physical address in this case. Physical address. What is the physical address? That nothing but your virtual address only 32-bit. So we need to divide into 3 parts, right? We need to divide into 3 parts. One is word offset, set line or set offset, and tag. Am I right? It because we have solved couple of problems in this case. Word offset directly depends on what? Block size only, right? Yes or no? Block size only. What is the block size? You can say block size 16 means 4. Set offset depends on the number of sets. How many sets are there? 2K. 11 bits required. So 11 plus 4 15. 11 plus 4 15. Then this is going to be 17. Correct? 17. Am I right? 17 only. Now what is the first question? What is the first question? First question says cache directory size. First question says cache directory or meta tag, that is nothing but number of cache block multiplied by tag bits. And if any additional tag bits given, we can add, but not given in the question. Number of cache lines, how many? 4K into tag bits, how many we got? 17. This is what 68 K bits, if I am not wrong. First question answer 68 kilobits. So cache directory we calculated previous question also, same thing we can do it. Fine. So look, question number 1, same. The total size of the tags in the cache directory or cache directory size, meaning is same. So means so number of tag bits multiplied by number of cache block. We observed also, meaning we understand, simply done. Second question, what is the cache hit ratio for this initialization of the program? Answering this question, we need to understand memory pattern, like how we stored, and cache pattern also we to understand, so that we can answer this second question. Look, let me arrange this thing. Fine. Oh, so first question got. Look into second question. So main memory size. Oh, main memory size. Please do understand main memory size. What is the main memory size? What is the main memory size here? Physical address, right? Physical address nothing but 32-bit. If I take, you can see, if you have a doubt, also you can see like this. What they said, are they given anything? Here you can see main memory starting at the beginning of the virtual page number. Virtual page number, this is 1, 2, 3, 4, 5. 5 bits, 20 bits, correct? 20 bits. 5 digits multiply by each digit 4, 20 bits will get. 20 bits means 2 power of 20, 1 million pages are there, that meaning. What is the page size they given here? What is the page size? They said, right, somewhere page size is given. I think previous only, like take. Page size how much? 4 KB. So now see, 4 KB, 1 million into 4 KB, how much will get? This is going to be 32-bit only, right? Means what? It is going to be 4 GB. If I am not wrong, getting my point. My program size is 32-bit, like 2 power 34 GB is the program size. Sorry, entire memory size. This is not required at all. We need to focus into my program size only. What is the program size? What is the program size? 8 MB, correct or not? 8 MB. Now number of blocks, how many will get in main memory? Number of blocks. Number of blocks in main memory. How many will get? 8 MB by 16 bytes. Yes or no? This is 2 power of 23 divided by 2 power of 4. So how much? 2 power of 19, correct or not? 2 power of 19, nothing but 512K blocks will get. 512K blocks. Suppose my program started, they said, right, some page number onwards, some number under onwards and that. So from here to will store somewhere. This is my program. This is program segment, array segment, please to understand. Okay, how many blocks? Suppose if I start this referring to 0, this is 1, this is 2. I'm not taking the global address, internal address of this program. Suppose somewhere address, this starting address of the program, they given already in terms of page number. In a page, blocks are stored. So 0, 1, 2, 3, like if I write it, 512K minus 1 blocks will be there here, correct? And what is the block size? Yes, what is the block size? Block size is 16 bytes. What is the element size? 2 bytes. Now please to understand number of elements. Number of elements in block, how many will be there? 2 only, correct or not? Are you getting my point? Because see, in the question, double element taking 8 byte, my blocks is 16 byte. One block you can place 2 elements only, please to understand. And how the program is placed? Row major order. So I'll start loading here. Please to understand. Okay, now this block size is 16 bytes, please do understand. So the confusion we may get here, sir, page size also given, 4 KB page size given, you saying block size. Please do understand, answering this question, we need to look into block organization only. Other way you understand, pages also internally divided into blocks here. 4 KB page divided into now again blocks also. Suppose you understand, somewhere is the page, like that. In a page also we have a blocks. So addressing into main memory may goes in terms of first identify the page number, then identify the block number, take the word number, that will go. So that organization would be there. Fine. Elements will be, so ARR of 0, 0, then next element ARR of 0, 1. Okay, similarly, next array will be 0, 2, this is a 0, 3. Getting my point? So this is a row major order. Please don't, first complete row will store, then next row, like that. We have sufficient number of blocks. 512k blocks are there. Please don't. 512k blocks are there. For storing this program, I stored this way. I stored. Initially, cache is empty. Getting my point? Initially, cache is empty. Out of which, what we noticed here, one block can hold two elements. That's what you understand. Getting my point? So please do copy this one so that I will remove. So I will take the cache here only so that we can understand. Getting my point? So some information got it here, right? Fine, look. So looking into cache. Okay, looking into cache. So what is cache? Is 64 kilobytes. Correct or not? So cache is also organized in terms of first block, right? Block. Okay. 1, 2, 3, 4. How many blocks are there? Yes, somebody comment it. How many blocks are there? We calculated, right? 4k. So if I start numbering 0, 1, 2, 3, 4, 5, 6, 7, 4k nothing but 4095. Total cache blocks are 4k, 4096, numbered from 0 to 49. So which way we use? Two-way set association. Two-way set association. Getting my point? Two-way set association. So because answering this question, this much hangama is not required, but try to analyze the memory patterns so that any new question comes, we'll get an idea to analyze the question. Fine. So two-way set association means you have to divide it like this is the division. This is a division goes like this. Okay. Goes like this. Two-way nothing but in each set there are two elements. So now 4k means how many sets will get? Number of sets how many? 2k only, right? Set number 0, set number 1, set number 2, set number 3, set number 4, like this. How many sets are there here? 2047. Are you getting my point? Total sets are 2048. 2k means 2048. Total sets are 2048, numbered from 0 to 2047. I hope you got it. Organization the cache memory under this mechanism. I hope you got total number of blocks. Then I organize in terms of total number of sets. How mapping goes? Any jth block of main memory map to number of sets v. Correct. Thus giving the set number. What is the v here? In our example, v is 2048. Please do note down this one. Number of sets are 2048. Any block you have to map to this. Now the CPU starts referring the address ARR of 00. Please do understand AR of 00. Initially cache is empty, mentioned in the clearly. So when the CPU referred this address, this first element, do you have in this element in the cache? No. First reference goes miss. Then what to do? The concerned cache block we need to bring from main memory and map it. So A of 00, nothing but first block only. First block, nothing but 0 block here. From my beginning of the program, somewhere you understand. So don't notice, like no need to notice about this, starting address of the memory. Look into your block number 0, assume it. If you take in terms of physical address also, things will be same only. 0 block. 0 block contain two elements. 0 modulo. So 0 modulo, it will go 0 modulo 2048. Getting my point? It is given 0 only. Set number 0. Please don't understand. Set number 0. In set number 0, there are two blocks are there. You can place anywhere. Either you can place here or here. Please do understand. Suppose if I want to place here, so it will come ARR of 0, next ARR of 0, 1. Getting my point? What is second reference goes? This is miss. Second reference ARR 0, 1. It is second reference by the processor. So is there a 0, 1? Yes, 0, 1 is. This is going to be 8. Getting my point? 8. Now third reference is 0 AR of 0, 2. Is there? No, miss. Please do understand simply what is the question they ask. Initializing this program, what is the it ratio? What is the it ratio for initializing this program? That's it. Is it right? So look the question once again. Question which given. What is the cache it ratio for this initialization of the program? So now tell me, quickly answer it. For every cache block access, one hit, one miss. So can I answer it simply? Second question, it ratio for cash. It ratio for cash is so much, 1 out of 2. This is 50% only. This is going to be what, 50%. I hope you got it. Yes, second question we answered 50%. This is what analogy. Suppose the set size, suppose bigger, not if it is not 2, if it is 4 is there, what happens now? Every 4 black first is miss, remaining is 3, it. So that way you can see that nothing but you understand 3 by 4 will be the it ratio. Here 50% is it ratio. So second question easily answered. See, understand that is what beauty of this computer architecture. Questions are very big. Questions looking is very big. Answering the question is very easy. So what is required to answer this question? Just this much not required to. For explaining things only I mentioned here. Simply just look into that one cache block, how many elements will occupy. That's only. One cache block, how many elements occupy? 2. First anyway 1 is missed, then second one will be hit only. That directly you can answer 50% of the iteration would be there. Now coming into third question. What is the third question says here? What the third question says? Yes, carefully understand. What is so copy, write out the note of the second question answer, that is 50%. Now third question, look carefully. Third question. Yes, what is the like which block of the cache, which block of the array, or which element of the array will overlap to this AR of 0001? Am I right? That only can look into third question. Which of the following array element has the same cache index? Cache index means the set number. Please, cache index nothing but set number. Getting my point? Set number is a cache index as 00. Which of the following index will be same? How to answer it? This is very required some analysis. Required analysis. See how many blocks are there? Like please don't. How many blocks are there? See now 512K blocks we have to map to 4K blocks only. Or sorry, 2K sets we have to map it. And array element which is overlapping to this one. So first you understand that the sequence of loading here. Look this. So one block, please, one block will have 2 elements, correct or not? One block will have 2 elements. To complete one row, how many cache blocks required? So are you getting my point? Are you getting my point? So I'm writing. Okay. So one block contains 2 elements, correct or not? 2 elements. That is like I can write 00 and 01, correct or not? This is the index, first one block. Like total one row containing what 1024. So for first row I am writing. To store first row, how many blocks required? 512 blocks are enough or not? Are you getting my point? First row 0 to suppose I want to know from here 002. Okay, 002 0 of 1023. This is entire first row. How many blocks required? 512 or not? Now please do understand. So 513th block contain the what? So like 1 of 0. Am I right? This is what index of 1 of 0 only. 513th block. Do you agree, all of you? 513th block 1 of 0 and A of 1 of 1. Am I right? This I am writing ARR. So I hope you are getting my point. So first block, any block, one block containing these 2 elements. First row of array, entire array, 1024 elements will be there, required to store 512 only, 0 to 511 only, you understand. So 511 only I have to take it. This is 512 start. 512th block having array of 1011. Getting my point? Next. So if I go similarly, if I write 1023 block has array element of what? ARR 1 of 1023. Do you agree this one? Last element of second row. So 1024th block contains ARR of 2 of 0. Getting my point? 1000 still, because how many sets are there? Total sets in our cache memory 204. It will be somewhere middle. Please do understand, like this you can see. So here. 2047 is a 1024 will be somewhere middle only. Still somewhere middle only I can say. 5 will be somewhere here like this. Somewhere it will be 1024. Still 2047 sets are there. I again 4096 blocks are there. I hope you getting my point. So similarly I will write getting sorry. So 1024th block containing array of 201. Correct or not? Similarly I will write it next point also. Let's see. Now 1024 next row, anyway each row contains 512, right? If I take 511, this is 53. So 15th 35th block, please do understand, block contains, check it, array of A or array of, okay, getting point. This will be 2 of 1023. Am I right? Am I right? You can see 1024 contain 2 of 0, end of third row, please do understand, first row is 0, second row is 1, third row is 2 onwards, like getting my point. So I hope you getting my point. 1535th location, that block has this array, correct on, this element is there, E element, then this A of A or R of 2 of, this is 2 2, this is 1023, if I am not wrong. Anything mistake I written here? Anything written? This is 1024 block 2 of 0 and this is 2 of 1. This is 1020, last block is nothing but 1 of last one, this is 2 and we can write 1 of 1023 because one block has 2 elements, right? 1022, 1023. Similarly, okay, here also same thing. Similarly, if I go 2047th block as last row of, like next 1536 will start third row, A of 30, right? This will containing ARR of 3, correct or not? 3 of 1022, comma ARR of 3 of 1023. Getting my point? I hope you getting. 2047, like if I write 15 and 36 will be starting of third, correct or not? Ending will be this one, correct or not? Suppose 2048, okay, 48th block, what is containing? ARR or 4, this is 0 and ARR of 4 of this one. Do you agree this point? 2048th block, getting because half of the element. Now, how many sets are there? Go to the point here. How many sets are there? 2048 sets are, total sets are 2048. Getting my point? Numbered from 0 to 2047. 2047 modulo 2047. Suppose 2048. This is 204. Here it will come. But after that, when you take 2048 as a block, please do understand. 2048 is a block. Modulo, we have to apply set number, total sets 2048 only, right? Means I am trying to understand which array element will overlap to set number 0, this index of A of 00. That I am trying to check. That is the reason checking the sequence here. That is the reason analyzing sequence here. 2047 we understand, 2047 modulo 2048 will be 2047 only, here I placed. Then when it is 2048 block containing the array of 4 of 0, 2048 where it will map? 2048 modulo 2048, that is giving the set number 0 here. So set number 0 I can place array here, because one set there are 2 blocks are there, so I can place A of ARR of 4 of 0 comma 4 of 1. You understand? See, now array of 4 of 0, 4 of 1 will be mapping to this index set number 0. So that was a question only. You can see the question. Which of the following array element has the same cache index? Cache index means set number. Because then one set there are 2 blocks are there, right? We cannot remove, we can be placed. Array of A of 0, 0. Same. So what is index for AR of 0, 0? Set number 0 only. For which of the following things we have? AR of 0, 4? No. AR of 4, 0? Yes. This is not possible, not possible. Getting my point. AR of 40 will be having the same index of this one, that you would understand. So getting my point, all of you, look here, look carefully. So look carefully, which I mentioned clearly. See, this analysis you have to do it. So 2047 is 3 will complete, then 4 will begin. 4 will begin. So that will be placed 2048 the block. 2004 the block will be mapped into set number 0 only. That will the map that we need to understand. Getting my point? Here we should not confuse here, like 1536 the block containing AR of, this will complete 3 of 0 comma AR of 3 of 1, that you have to understand. This you have to understand. So like every like 512, because one row having 1024 can be placed into 512 blocks only. That is what analyze I did. So 0 to 511 tak one row will complete. 512 onwards to 1020 the second row will complete. 1024 to 1535 the third row will complete. 1536 to 2047 fourth row will complete, and 2048 will start fifth row. Fifth row nothing but your array element nothing but 4 of 0, because my array started from 0 onwards, right? The fifth row will stored into 2048, that will map. So that we need to notice. So out of this question, this very beautiful question, reason please understand. So a lot of analysis we need to do here. So out of which what I hope you got it, pattern for writing the program, like storing the program in main memory, and looking into cache organization in terms of blocks and sets, and mapping this array elements to the set. So mapping the array elements into the cache memory as well as the main memory. I hope you got the point. So some more couple of questions we can discuss under on cache address mapping methods, because this is most important topic. Because science student, most of the student will lag with mapping of the things, organizing the data in the memory, only this lagging. I hope you will find something good in this video. Thank you all. Thank you so much.